Beneath the rolling blue that stretches endlessly across our planet lies a world so vast, so alien, and so unyielding that even now, in an age of satellites and supercomputers, it remains mostly uncharted. The ocean covers more than 70% of Earth's surface, yet for most of human history, it was not seen as a realm to be explored. It was a mystery to be feared. To our ancestors, the sea was both lifeline and monster, a surface that shimmered with promise, but hid a darkness no one could fathom. Ships sailed across its skin, but few dared to imagine what lay beneath. For centuries, people believed the ocean floor was lifeless, a barren, cold desert of mud and silence. The deeper you went, the more it became a place beyond life, beyond light, beyond meaning. This belief wasn't born out of ignorance, but out of the limits of what could be observed. The sea resisted exploration. It swallowed tools, crushed equipment, and obscured vision. Even when humans began to map continents and skies, the deep sea remained a blank space, a mystery as infinite as the cosmos. The idea that something could live in that eternal darkness was almost unthinkable. But curiosity is a stubborn thing. From the first time humans looked out over the horizon and wondered what lay beyond, that same impulse eventually turned downward, toward the deep. The first explorers of the ocean's depths weren't divers or submariners, but natural philosophers and sailors with ropes, weights, and imagination. They lowered lead lines from wooden ships, hoping to measure the ocean's depth. Sometimes they hit the bottom. Sometimes the rope ran out. To them, the sea's vastness was not just physical. It was existential. Each failed attempt at sounding the deep was a reminder of human smallness, of how little we could touch the world we lived on. Then came a transformation, one that began not in the ocean, but in the way we thought about it. As science grew in the 18th and 19th centuries, so did the belief that the natural world could be measured, mapped, and known. The earth was no longer a mystery to endure. It was a puzzle to solve. The ocean, that ancient enigma, became the next frontier. Explorers and scientists began to ask new questions. What lies at the bottom? How deep does it go? And perhaps most importantly, is there life down there? The early answers came slowly and often through mistake and myth. In the mid-19th century, a naturalist named Edward Forbes proposed what became known as the azoic hypothesis. He believed that below a certain depth, about 300 fathoms, life could not exist. His claim was bold, and it fit neatly with what most people already believed, that the deep sea was dead. For decades, this idea went unchallenged. After all, no one could prove otherwise. To descend to such depths was impossible with the tools of the time. The ocean's mystery remained intact, sealed beneath miles of pressure and darkness. Yet the truth was waiting, silent and patient, at the bottom of the world. The turning point came when technology began to meet curiosity head-on. Advances in dredging, the practice of dragging nets or scoops along the seafloor, allowed explorers to haul up samples from previously unreachable depths. To their astonishment, they began to find life. Strange, delicate creatures emerged from the darkness. Brittle stars, worms, mollusks, and corals, some glowing faintly even after death. The discovery shattered the azoic hypothesis and redefined humanity's understanding of the deep. The ocean was not a wasteland. It was an ecosystem, complex and alive. This revelation sparked a new age of exploration. What had once been a realm of sailors and myth-makers now drew scientists, engineers, and dreamers. Ships set out not just to sail, but to study. They carried instruments, thermometers, dredges, nets, and bottles that could trap water from precise depths. Each voyage became a step into the unknown. And with every haul from the abyss, the world grew stranger. Creatures unlike anything seen on land began to emerge. Transparent bodies, enormous eyes, luminous organs that glowed in the dark. It was as if another planet had been discovered right here on Earth. But the ocean does not give up its secrets easily. For every discovery, there was failure, instruments lost, samples destroyed, data corrupted by the elements. Even so, the momentum built. The sea, once thought unknowable, began to reveal its patterns. Currents, temperatures, salinity, and life, all interconnected in a grand system far more intricate than anyone had imagined. To study the deep sea was to study the planet itself, from its past to its living present. One expedition, in particular, would mark the beginning of modern oceanography. In the 1870s, a ship was sent to conduct the first systematic exploration of the world's oceans. Over nearly 4 years, it sailed around the globe, collecting samples, measuring depths, and documenting thousands of species. When the ship returned, it brought with it the first real portrait of the deep ocean, a world teeming with life, shaped by unseen forces and far from empty. The data gathered filled volumes, transforming how humanity perceived its own planet. For the first time, we understood that the deep sea was not a void, but a vast, dynamic realm that governed climate, life, and even the chemistry of the air we breathe. The revelation was profound, but it also sparked a more subtle shift, an emotional one. To know that life thrived in such darkness challenged old notions of where life belonged. The ocean's depths became a symbol of both the power and the humility of human curiosity. We realized that there were frontiers not only out there in space, but right here, under our feet, waiting to be explored. The deep became a mirror for the unknown within ourselves, the part of our world and our nature that remained hidden until we dare to look deeper. By the end of the 19th century, the ocean had gone from an inscrutable void to a living, breathing system, vast beyond comprehension, but no longer invisible. Humanity had finally begun to fathom the sea, both scientifically and spiritually. Yet the deeper we looked, the more we understood how little we truly knew. The discoveries of the early oceanographers opened the door to a mystery even greater. If life could exist in places of crushing pressure and eternal darkness, what else might the ocean be hiding? That question would drive the next century of exploration, a journey not only into the depths of the sea, but into the limits of human imagination. By the dawn of the 20th century, humanity had only skimmed the surface of its greatest frontier. The deep sea had shifted from myth to science, but its true nature still eluded understanding. What explorers discovered was that the deeper they looked, the less familiar the world became. The sea, they realized, was not one world but many, each layer different in pressure, light, and life, like a series of hidden realms stacked one atop another. To explore it meant crossing invisible thresholds where the rules of existence changed. Near the surface, sunlight nourished everything. Fish darted among coral reefs. Plankton drifted in endless bloom, and color filled every inch of the water. But just below, at about 200 meters, light began to fade. Beyond that depth, the ocean turned a cold, perpetual twilight. Then came the darkness, absolute, complete. This was the midnight zone, a realm without sun or shadow, where the only light came from the creatures themselves. Here, life had evolved in ways that defied every rule known on land. Bioluminescence, the ability to produce light, became the ocean's most elegant invention. From tiny plankton to massive predators, countless species glowed, blinked, and shimmered in patterns that scientists struggled to decode. Some used light to lure prey, others to confuse predators or to communicate in the dark. To a human observer, the deep sea would appear like a star field turned upside down, galaxies of living light swirling in total blackness. The discovery of bioluminescent life changed not only marine science, but also human imagination. It was proof that life could adapt not just to survive, but to flourish under conditions that seemed impossible. And yet, even with this revelation, explore that world was nearly impossible. The deeper explorers tried to go, the more nature resisted them. Pressure increased by 1 atmosphere every 10 meters. At 1,000 meters, that's the equivalent of a small car pressing on every square inch of your body. At those depths, air would compress to liquid, metal would buckle, and glass would shatter. The human body was fragile in comparison, and for decades, it seemed that the deep sea would remain beyond our physical reach. But curiosity doesn't accept boundaries easily. If the ocean couldn't be entered directly, it could be touched through machines. Engineers and scientists began designing new kinds of instruments, dredges, water bottles, thermometers, and eventually, machines capable of descending far below the surface. These early inventions were primitive, but they changed everything. They could record temperatures, capture samples, and map the seafloor in ways no human diver ever could. Slowly, the contours of the deep began to emerge. Mountains, trenches, canyons, and plains, far more complex than anyone had imagined. The seafloor was not a flat desert as once believed. It was a landscape of extraordinary drama. There were underwater volcanoes, rift valleys, and vast ranges of mountains higher than the Himalayas. It became clear that the ocean was not merely a container of life, but a living system, dynamic, shifting, constantly reshaping the face of the planet. Every current, every chemical reaction, every living creature was part of an immense and interconnected web. The more we learned, the more we understood that the deep sea was not separate from life on the surface. It was its foundation. In the mid-20th century, a new era of exploration began, one that would finally allow humans to see the deep sea with their own eyes. The invention of the bathyscaphe, a small, self-propelled submersible, changed everything. Unlike earlier submersibles that were tethered to ships, the bathyscaphe could dive freely. In 1960, 2 men descended in one of these vessels, the Trieste, into the Challenger Deep, the deepest known point on Earth, nearly 11 kilometers down. It was a descent into an environment more hostile than any other on the planet. For nearly 5 hours, they sank into the black. The deeper they went, the more the sunlight faded until there was only darkness and the sound of creaking metal. At that depth, the pressure was over 1,000 times greater than at the surface. If even a small crack had appeared in the vessel, it would have been crushed instantly. And yet, they reached the bottom, a desolate plain of fine sediment, eerily still. What they saw shocked them. Life, small, translucent creatures stirred in the mud. Against all odds, life existed in the most extreme place on Earth. That moment redefined what habitable meant. The boundaries of life stretched farther than anyone had believed possible. If organisms could thrive there in crushing darkness, perhaps they could exist in other worlds too, beneath the ice of Europa or Enceladus, or in the subsurface oceans of distant planets. The deep sea was no longer just an earthly frontier. It had become a mirror for the cosmos, a model for life's resilience everywhere. But with each triumph came new frustration. Seeing the deep sea did not mean understanding it. Visibility was poor, communication nearly impossible, and the environment itself destructive to instruments. Submersibles could only stay down for short periods, and the area they could explore was minuscule compared to the ocean's immensity. Even with sonar and cameras, mapping the seafloor was painstakingly slow. To this day, we have mapped Mars and the Moon in greater detail than our own ocean. Still, the glimpses we gained were enough to ignite wonder. Scientists discover hydrothermal vents, cracks in the seafloor where superheated water rich in minerals erupted into the abyss. Around these vents, life gathered in dense colonies. Giant tube worms, clams, crabs, and strange microbes that fed not on sunlight, but on chemical energy from the Earth's core. It was an ecosystem that operated entirely without photosynthesis, thriving in what had once seemed impossible conditions. These vents revealed something profound, that life could arise and sustain itself in complete isolation from the sun. It was a revelation that rewrote biology itself. For centuries, we had believed that the sun was the ultimate source of life. But the deep sea showed us that Earth held other forms of energy, older, more elemental, and that life was capable of adapting to them. The discovery of chemosynthesis, the process by which these organisms converted chemical energy into living matter, opened an entirely new chapter in our understanding of what it means to live. The ocean had taught us something humbling. The boundaries of life are not fixed, and the definitions we create are limited by the places we can reach. The more we explored, the more those definitions had to expand. The sea was no longer a backdrop to human history. It was the main stage. Its depths held not only creatures and landscapes, but also ideas, reminders of how fragile and interconnected life truly is. Yet, for all our progress, the deep ocean remains a mystery. More than 80% of it is still unexplored, and much of what we think we know is based on fragments, samples, sonar images, and fleeting glimpses through the windows of submersibles. The deeper we go, the more questions we find. What species live beyond our reach? How does the ocean influence the planet's climate in ways we cannot yet measure? And what secrets still lie hidden in the darkness, waiting for the next daring descent? The journey into the deep sea is not just a quest for knowledge. It's a reflection of our need to explore, to understand, and to find meaning in the unknown. Every dive, every discovery, every small piece of data pulled from the abyss is part of a greater story. A story about curiosity, persistence, and the strange, beautiful relationship between humanity and the ocean that birthed it. The deeper we journeyed into the abyss, the clearer it became that the ocean was not just another ecosystem to catalog. It was a living archive of Earth's history, a memory of the planet written in water and stone. Every layer of sediment, every chemical signature in the deep currents, whispered stories of ancient cataclysms, shifting climates, and vanished species. The ocean did not simply sustain life. It preserved its evolution. To explore was to peel back the layers of time itself. By the mid-20th century, scientists had begun to understand this. The deep sea was no longer seen as a static, timeless void, but as a dynamic part of Earth's machinery. The sea floor moved, cracked, and rebuilt itself over millions of years. Mountains rose and fell beneath the waves. Continents drifted, powered by forces invisible yet constant. The theory of plate tectonics, which explained how the Earth's crust moves, found its strongest evidence beneath the oceans. The seafloor was not ancient at all. It was continually being renewed at mid-ocean ridges and consumed in deep trenches. The ocean, it turned out, was the heartbeat of the planet. Yet to glimpse this truth required technology and vision beyond anything humanity had attempted before. As the Cold War raged above, it also pushed exploration below. Military funding, driven by the need to understand submarine warfare and sonar detection, inadvertently fueled a golden age of ocean science. Networks of sensors, deep-sea mapping systems, and submersibles capable of venturing thousands of meters down were developed. What began as strategic necessity became a revolution in discovery. For the first time, humans could see the seafloor in detail. Vast underwater mountain ranges, the mid-ocean ridges, spanned the globe like the seams of a baseball. Deep trenches, such as the Mariana and Tonga, marked places where one tectonic plate sank beneath another. Volcanic activity at the ridges created new crust, while earthquakes along the trenches reshaped the planet's surface. These discoveries revealed that the ocean was not just a passive basin, but an engine of geological change. The Earth was alive beneath the sea, in ways far more dramatic than anyone had imagined. And yet, even amid these triumphs of science, the ocean kept its distance. The deeper we looked, the more we realized how fragile our understanding was. Instruments malfunctioned under crushing pressure. Submersibles cracked or imploded. Samples were contaminated or lost. Each successful mission was built on dozens of failed attempts. The ocean demanded humility. It rewarded persistence but punished arrogance. It was, as one explorer put it, a place where human technology goes to die. Still, the human spirit refused to retreat. Explorers returned again and again, drawn not only by curiosity, but by something more personal, the feeling of touching the unknown. To sit in a small steel sphere, surrounded by darkness and silence, thousands of meters below the surface, is to confront the limits of human experience. There are no landmarks, no points of reference, only the hum of machinery and the pulse of your own heart. In that vast emptiness, one feels both insignificant and infinite, a speck of light suspended in the deep's eternal stillness. It was in those depths that some of the most profound discoveries were made. The existence of hydrothermal vents, for example, forced scientists to rethink the very origins of life. Here, where scalding water gushed from cracks in the ocean floor, surrounded by complete darkness and immense pressure, life flourished without sunlight. Chemosynthetic bacteria formed the base of a food chain that supported giant worms, crabs, and fish, an entire ecosystem powered by the Earth's internal energy rather than the sun. This realization changed everything. If life could thrive here, it could exist anywhere, on frozen moons, on planets beneath thick clouds, even in alien oceans light years away. The deep sea became a proxy for the cosmos, a living laboratory for understanding the conditions that make life possible. The boundaries between biology, geology, and astronomy began to blur. In studying the deep, humanity was, perhaps unknowingly, preparing to look beyond Earth. But as much as we learned from these depths, we also began to understand how fragile they were. The same forces that made the deep sea mysterious also made it vulnerable. Human activity, pollution, mining, and overfishing began to reach even these remote places. Plastics have been found in the stomachs of creatures miles below the surface. The roar of shipping traffic echoes to the water, disrupting the songs of whales. The ocean, once thought untouchable, bears the marks of our presence even in its darkest corners. And yet, paradoxically, this vulnerability only deepens our sense of wonder, because in the face of destruction, the ocean continues to adapt. Its resilience, though not infinite, is astonishing. Scientists have found bacteria capable of breaking down oil, corals that can withstand acidification, and species that thrive amid the wreckage of shipwrecks and debris. Life, it seems, does not surrender easily, even in a world reshaped by human hands. This relationship between discovery and consequence, knowledge and responsibility, became one of the defining themes of modern ocean exploration. To explore is to change, and the ocean, more than any other place on Earth, reminds us of the cost of curiosity. Every instrument lowered, every sample taken, is an intrusion into a delicate, ancient world. The challenge now is not just to explore the ocean, but to do so with respect, with the understanding that our desire to know must be balanced with a need to protect. Yet, even with these concerns, the pull of the deep remains irresistible. Each discovery, no matter how small, hints at another layer of mystery. Entire mountain ranges still lie unseen. Unknown species drift through the abyss. The chemistry of deep currents, the migrations of creatures that never see the light, all remain partly unsolved. For every answer, 100 new questions rise to the surface. The ocean, in this way, mirrors a human mind, vast, layered, full of hidden depths. We chart what we can, but most of it lies in darkness, unknowable yet profoundly connected to the surface world we inhabit. Perhaps this is why we are drawn to it. The deep sea reflects something essential about ourselves. It is both alien and intimate, terrifying and beautiful, a reminder that knowledge is never complete and that wonder endures precisely where certainty ends. By the end of the 20th century, our relationship with the ocean had transformed completely. It was no longer the unknowable void our ancestors feared, nor simply the scientific frontier our explorers sought to conquer. It had become something far more nuanced, a mirror of our curiosity, our power, and our fragility. The deep sea was not just a destination. It was a dialogue, an ongoing conversation between humanity and the planet that made us. And that dialogue is far from over. The ocean still holds its secrets, waiting patiently in the dark. The question now is whether we can learn to listen, to explore not with conquest in mind, but with reverence. Because the deeper we look, the clearer it becomes that the ocean's mysteries are not separate from us. They are the stories of our own beginnings, and perhaps our future as well. In the end, the greatest revelation the ocean offers isn't found in its creatures or its currents, but in what it teaches us about our place in the universe. To explore the deep is to confront the truth that knowledge has boundaries, and that some mysteries endure not because they are unsolvable, but because they remind us of humility. Even now, in an age of robotic submarines, high-resolution sonar, and satellites that can map the planet's surface from orbit, more than 80% of the seafloor remains uncharted. The ocean keeps its silence, guarding secrets that no machine can yet penetrate. And perhaps that's fitting. For all our progress, the ocean remains one of the last wild places. Not wild in the sense of chaos, but wild in its refusal to be owned, understood, or subdued. It humbles us. Each time we reach a new depth, we find not an ending but beginning. Every descent reveals that the unknown is vaster than we imagine, and that curiosity is not a conquest, but a conversation, one between life and the forces that shaped it. The irony is that our species depends utterly on the ocean, yet most of us have never truly seen it. The sea regulates the air we breathe, absorbs the carbon we produce, and stabilizes the planet's climate. It feeds us, carries our goods, and links our continents. Its rhythms are the pulse of the earth itself. But beneath the surface lies a world that continues to defy comprehension. The deep sea's creatures, luminous, translucent, unearthly, exist in conditions that seem impossible, each one a testament to life's relentless adaptability. Their existence challenges every assumption we've ever made about what life needs, what it can endure, and where it can thrive. Some scientists now believe that the deep ocean may hold the key to understanding life's origins. The vents and mineral-rich zones discovered miles beneath the waves are thought to mirror the conditions of the early Earth, where heat, pressure, and chemistry combined to spark the first living cells. In the ocean's depths, The past and present coexist. To look down into that blackness is to look backward in time, toward the beginning of all living things. Yet, even as the deep sea reveals glimpses of its beauty, humanity's presence is felt there too. Tiny plastic particles swirl in trenches 7 miles deep. Microbes feed on chemical waste from human industry. The ocean, once the most pristine realm on Earth, now bears the fingerprints of our civilization. We are connected to it not only through wonder, but also through consequence. The very technologies that allow us to explore the ocean also threaten it. Mining operations scrape the seafloor. Trawlers tear through fragile ecosystems, and carbon emissions warm and acidify the water at a pace unseen in millions of years. The deep, which once seemed eternal, is changing, and faster than we can study it. Still, there is resilience in the darkness. Life adapts, as it always has. New species continue to be discovered, each one stranger and more astonishing than the last. Some of these organisms possess biochemistries that could revolutionize medicine, offering clues for new antibiotics, painkillers, and materials that resist heat and pressure. The ocean's hidden biology may yet prove to be one of humanity's greatest teachers, if we can learn to listen before we destroy what it has to show. In a sense, the deep ocean has become the last mirror of mystery in a world where everything else is mapped, digitized, and known. It reminds us that wonder still exists, that even on this well-explored planet, there are places untouched by light, inhabited by beings that know nothing of our world. It challenges the illusion that humanity stands apart from nature. Down there in the cold and silent dark, the boundaries between life, matter, and time blur. The creatures that live there are not separate from us. They are part of the same story, written in different conditions but born from the same earth. And perhaps that is what draws us back, again and again, the need to feel that connection, to touch something beyond comprehension. Each dive, each expedition, each fleeting image of a creature never seen before, brings with it a sense of all that transcends science. In that moment, we are reminded of the simple truth that exploration is not only about discovery, it is about understanding who we are. The ocean's mysteries echo our own inner depths, our capacity for curiosity, resilience, and reverence. Yet, for all our efforts, the ocean's greatest secret remains the same: its silence. No matter how advanced our machines become, there is a limit to what data can convey. There are sounds, textures, and sensations that cannot be translated. The hum of pressure, the shimmer of bioluminescence, the immense weight of water pressing from every direction. To experience the deep is to encounter the boundary between the measurable and the ineffable. It is a reminder that science and wonder are not opposites. They are partners. One seeks to describe the world. The other gives it meaning. As humanity continues to reach farther, into the stars, into artificial intelligence, into the very fabric of the atom, the ocean remains a grounding force. It is the planet's oldest mystery and its most enduring. Long before we looked to the heavens, we looked to the sea. It has shaped our myths, our migrations, and our imaginations. And now, as we stand on the edge of another century, it calls to us again, not as conquerors, but as caretakers. To truly explore the ocean, we must accept that we may never master it. Its darkness is not meant to be conquered, but respected. Its silence is not emptiness, but depth. And its mysteries are not obstacles to be solved, but reminders of how vast, fragile, and extraordinary our world really is. So perhaps the question was never, why can't we truly explore the ocean? But rather, why do we need to? Because to explore is to remember our connection to the unknown, to reach beyond what we understand, and in doing so, rediscover our own capacity for awe. The ocean's greatest gift is not its secrets, but its silence, a silence that invites us to look inward, to reflect, and to listen to the heartbeat of the planet that gave us life. And in that listening, in that humility before the vastness of the deep, we find something greater than discovery. We find perspective. We find belonging. And in the quiet, endless darkness of the ocean, we find ourselves.